Good day, everyone. Today we're diving into a key concept in trigonometry, the reference angle. The reference angle is the acute angle, less than 90 degrees, formed by the terminal side of an angle and the x-axis. Now, let me explain the parts of an angle. First, we had two types of sides of an angle. The first is initial side, which is this is where the angle starts and it's always along the positive x-axis. There is no movement or rotating happen. And the second is terminal side. Terminal side is the moving ray, which determines the position of an angle after rotating. And here is something important in trigonometry. There are positive and negatives angle. If the terminal side rotates counterclockwise, our angle is positive. If it rotates clockwise, our angle is negative. Positive angles. Will be the direction of all the degrees in quadrants. And if it's negative angles, will be the direction. Okay, let's now look at how to find the reference angles in all four quadrants. To find the reference angle of quadrant 1, we need to use the formula of the quadrant 1. To find these degrees easily, we need to use protractor. Protractor will help us to find the exact numerical of our angles. 40. Since our angle is 40 degrees and our reference angle is 40 degrees, our rotation will be counterclockwise. Ta-da! So in this example, we have an angle of 150 degrees. The formula of this. So our reference angle is 30 degrees. We need to find the angle of 150 degrees. Now, since our angle is 150 degrees and our reference angle is 30 degrees and they are both positive, our rotation will be counterclockwise. In the example of quadrant 3, we had an angle of negative 160 degrees. To find the reference angle, we need to use the formula of quadrant 3 for negative. So, negative 160 degrees plus 180 degrees is equals to 20 degrees. Since our angle is negative 160 degrees, we need to turn our protractor upside down. Since our angle is negative 160 degrees, our rotation will be clockwise. And our reference angle is 20 degrees, our rotation will be counterclockwise. Example of quadrant 4. We have an angle of 330 degrees. Again, we need to use the given formula of quadrant 4. And 30 degrees will be our reference angle. Since our angle and reference angle are positive, our rotation will be counterclockwise.
Good day everyone, I'm Kesha Elayat from 11 St. Ambrose. Today I will discuss what are the quadrant 1 to 4 in positive and negative angles. First, quadrant 1 is covered of 0 degree to 90 degrees. Next, quadrant 2 is covered of 90 degrees to 180 degrees. Third, quadrant 3 is covered of 180 degrees to 270 degrees. Lastly, quadrant 4 is covered of 270 degrees to 360 degrees. First, quadrant 4 is covered of 0 degree to negative 90 degrees. Next, quadrant 3 is covered of negative 90 degrees to negative 180 degrees. Third, quadrant 2 is covered of negative 180 degrees to negative 270 degrees. And lastly, quadrant 1 is covered of negative 270 degrees to negative 360 degrees.
Identify the given angle. If the angle is greater than 360 degree or less than 0 degree, reduce it to an equivalent angle with 0 degree and 360 degree by adding or subtracting multiples of 360 degree. So, I'm gonna teach you on how to solve the given angle. The first thing to do on how to solve it is to find the quadrant. Quadrant for positive angles. Quadrant 1 is 0 degree to 90 degrees. Quadrant 2, 90 degrees to 180 degrees. Quadrant 3 is 180 degrees to 270 degrees. For quadrant 4 is 270 degrees to 360 degrees. For negative angles, quadrant 1, negative 270 degrees to negative 360 degrees. Quadrant 2, negative 180 degrees to 270 degrees. Quadrant 3, negative 90 degrees to 180 degrees. Quadrant 4, 0 degrees to negative 90 degrees. This is the formula of the quadrant. For example, is negative 120 degrees. Since negative 120 degrees is in negative angles, so find it into a formula since the quadrant is 3. And here's on how to solve it.
Hello there, I am Angelica Buse, and I will be discussing the step 3 on the step-by-step process. So for the step 3, we have to determine the quadrant. So basically, we have to identify the quadrant where the terminal side of the angle lies. For example, the given Reference angle is 90 degrees. And basically, 90 degrees is under the coverage of the first quadrant, so it would lie on the quadrant 1. Another example is that the given reference angle is 160 degrees, and 160 degrees is under the coverage of the quadrant 2, so it will lie on the quadrant 2. This is essential because the quadrant determines how the angles will be calculated. Therefore, we have to calculate the reference angle using different kinds of formulas basing on what quadrant is given. If the given angle is under the quadrant 1 and it is on the positive side, we will use the formula of reference angle is equals to the angle given. And if the angle is on the negative side, we have reference angle is equals to the angle given plus 360 degrees. Or reference angle is equals to given angle plus 2 pi. And now, if the given angle is under the quadrant number 2 and the given angle is under the positive sign, we will use the formula of reference angle is equals to 180 degrees minus the given angle. Or reference angle is equals to pi minus the given angle. And if the given angle under quadrant number 2 is on a negative angle, we will use the formula of reference angle is equals to the absolute value of the given angle plus 180 degrees, or reference angle is equals to the absolute value of the given angle plus pi. And if the given angle is under the quadrant number 3 and it lies on the positive angle, we will use the formula of pi is equals to the given angle minus 180 degrees, or reference angle is equals to the given angle minus pi. And if it lies under the negative angle, the formula we will be using is reference angle is equals to the given angle plus 180 degrees, or reference angle is equals to the given angle plus pi. Lastly, if the given angle is under the quadrant number 4 and it lies on the positive angle, we will use the formula of reference angle is equals to 360 degrees minus the given angle, or reference angle is equals to 2 pi minus the given angle. And if the given angle lies on the negative angle, we will use the formula of reference angle is equals to the absolute value of the given angle. Now that you know the step-by-step process, let us now try to solve some problems combining all those steps. And our first problem, or our first example, is 80 degrees, and 80 degrees lies on the quadrant 1. Therefore, if it lies under the quadrant 1, we will use the formula of reference angle is equals to the given angle.
data plus 180 degrees. So the data is negative 120 plus 180 degrees. The answer is positive 300. Next example is 80 degrees. 80 degrees is a positive. So find the quadrant that positive angles. So the quadrant is 1. So let's see the formula of positive quadrant 1. The formula is data only. So the answer is 80 again. Last example, 5 pi over 3. Need to convert to find in which quadrant is placed. So here's the tutorial on how to convert 5 pi over 3 times 180 over 5. So the answer is 300. So find the quadrant that 300s are belong. So the quadrant is 4. And this is the formula of quadrant 4. 2 pi minus data. 2 pi minus 5 pi over 3 is equal 1 pi over 3. So this is the final answer.
Hi everyone, I'm gonna teach you how to find the exact value of trigonometric function using the reference angle. We need to follow some steps to find the exact value of trigonometric function using the reference angle. Our first step is we need to determine the reference angle. And we need to use the appropriate formula based on the quadrant. Our second step is we need to evaluate the trigonometric function of the reference angle and compute the value of the function for angle. Here's the example that we can put directly on the calculator and solve it without a calculator. Here's our first example. Our first example is sine 30. When we put sine 30 on the calculator, it results 1/2. And if we don't have a calculator, we can use the right triangle to determine the 30 angle of 30, 60, 90. So this is the 30, and its mean sine is so it's opposite and hypotenuse. Our opposite of sine 30 is 1, and our hypotenuse is 2. So the result is 1/2. So the answer is 1/2. Our second example is tangent 60. So tangent 60 is TOA. So it means opposite and adjacent. And when you put tangent 60 on the calculator, we will get square root of 3. When we solve it without calculator, so what like I said is tangents is TOA, so it's opposite and adjacent of 60 angle. So this is the 60 angle of our right triangle of 60, 30, 60, 90. And our opposite is square root of 3. And our adjacent is 1. So when we times these two into square root of 3 both sides and cancel the upper part, we will get square root of 3. So the answer is square root of 3. And our last examples is cosine 45. We can put this directly to the calculator and get square root of 2 over 2. When we solve it without a calculator, we need to find the opposite and hypotenuse of 45 right triangle. So this is the 45 right triangle, here's the 45, and this is the 45 right triangle. So our opposite here of 45 is 1, and our hypotenuse is square root of 2. We need to times it both side with square root of 2, and we will get the equal of square root of 2 over 2. So this is the final answer. We cannot simplify it. So, and that's how you find the exact value of trigonometric function using the reference angle.
Step 3. Determine the sum trigonometric function. To determine the sum of trigonometric function, we will use a ASTC rule. ASTC rule. A is for all functions are positive in quadrant 1. S is equals to sine and cosecants are positive in quadrant 2. T, tangent and cotangent are positive in quadrant 3. C is cosine and secant are positive in quadrant 4. Step 4. Apply the sign. Adjust the value from step 2 based on the sign determines step 3 that uses a ASTC rule. Here's a given example. Sine 210. Find the reference angle of sine 210. So 210 minus 180 degrees equals to 30 degrees. And after that, evaluate the sine 30 degrees. So 30 degrees is equals to 1 half. So determine the sign. Sine is negative in quadrant 3 because in quadrant 3, tangent and cotangent are positive in quadrant 3. So the final answer is sine 210 is minus 1 half because of ASTC rule.